Hello, ladies and gentlemen. Welcome to Work, Energy, and Power, Lesson 2, Power, Part 2. So, how long does it take a 12-watt motor to lift a 7-kilogram load up 5 meters? Well, as we said, here's the load going up. Power is work done per unit time, which is force times distance divided by time, MAD, or MGH. Now, I suggest we use MGH divided by time. Now, oh, come on, try that again. Now, here we want to solve for time. So I rearrange this. Cross multiply. Come on. Time is MGH over P. I feel like rearranging it. 7 kilograms times 9.81 meters per second squared times height, 5 meters, divided by power, 12 watts. The time I get 29 seconds. Okay. Now, a 200-watt motor is being used to lift shingles at a constant velocity to the top of a roof. If one pack of shingles has a 20-kilogram mass, determine the velocity that the pack will be raised at. Going up, power is work done per unit time, force distance over time, MAD over time, MGH over time. Now, here, I want to point out something. Using MGH over time. Oh, come on. Now, we're looking for velocity. What is velocity? Well, velocity is distance travels divided by time. So I can write this mgv, or force times velocity. So there's another formula for power we have to use. And we just arrived at another formula. So 200 watts equals 28 kilograms times 9.81 meters per second squared times velocity. That's 200 watts is 274.766 newtons times V. Divide both sides by 274.66 divided by 274.66. Velocity is 0.728, sorry. Okay. Now, okay, one last question. Bob pushes a loaded grocery cart, a couple more questions, but Bob pushes a loaded grocery cart across the 19-meter Sobeys parking lot in 10 seconds. If the cart has a mass of 44 kilograms with mu 0.280, what is his power? So here we have to do a free body diagram. Force applied, force friction, force normal, force gravity. We're only interested in the the x-axis, or going across. Power is work done per unit time, force distance per time, force times velocity. Here. Cars and mass okay, across parking lot in 10 seconds. Now, here it's implied that V is constant. If it wasn't, we would talk about V initial, V final, acceleration, displacement, time. Velocity is constant, then A is 0, which means F net is 0. If F net is 0, then force applied equals force of friction. So we don't know the force applied, but we know force of friction is mu, force normal, which is mu mg. that would be 0.280 times 44 kilograms, 9.81 meters per second squared. So force applied is 120.85 newtons. Now, we have to figure out the power. I'm going to change colors here because I can. Power, force times distance divided by time, is 120.85 newtons times the distance was 19 meters. Time was 10.0 seconds. 229.6 watts. 2.3 times 10 to the 2 watts if we want to get picky about significant digits. Now, two things to note, or actually one thing to note. An old unit of power is the horsepower, HP. 1 horsepower is 746 watts. No, I don't expect you to memorize it. If I wanted you to know this, particularly, I would write it on the formula sheet. But the question would be, what is the horsepower of a 1200 watt motor? Well, 1200 watts times 1 horsepower divided by 746 watts is 1.6 horsepower. So a 746 watt motor is the power of 1 horse, or thereabouts. Now, I could give you a question like this. Mr. Laflamme's airplane engine exerts a thrust of 1.34 times 10 to the 5 newtons when flying at 302 kilometers an hour. What's the horsepower of the engine? Now, divide by 3.6. That works out to be 83.9. Now, the horsepower of his engine. So there's the free body diagram. Power, work divided by time, force distance over time, MAD over T, MGH over T, times velocity. Now, sorry, blathering to myself. Do you have to write out all these versions of the formula? No. Do you have to be able to remember them? No, because they're written on your formula sheet. If not, write them on your formula sheet now. All right? And I think it's fairly obvious we're using this one. So, power is force times velocity, 1.34 times 10 to the 5 newtons times 83.9 meters a second. Getting power is times 10 and 7 watts. Now, times 1 horsepower divided by 746 watts. 15,000 horsepower. Well, 15,066. 1.5 times 10 to the 4 horsepower. It's a fairly powerful motor for an airplane. Well, depending on the size of the airplane. Anyway, that's what I expect you to know and be able to do for power. Any questions, shoot me an email. Otherwise, congratulations and good luck. Go do the homework.